Hello viewers, in today's session we are going to discuss an important type of indefinite integration in which the form is of this type, that is we have a quadratic function in the numerator and another quadratic function in the denominator under the square root sign, right? So here we have q1 as the first quadratic function and q2 is the second quadratic function, right? So here we'll see how we can integrate these type of integrands where we have q1 divided by square root of q2, where q1 is the quadratic function of the type ax square plus bx plus c, and q2 is another quadratic function of this type, say px square plus qx plus r, right? So we'll see how we can express this function, that is q1 over square root of q2, to get the indefinite integration of this function. So let us start. So the method to integrate these type of functions is that we express this q1 as a times q2, and then we have here b times the derivative of q2 and plus e, right? So if we take q1 as ax square plus bx plus c, then ax square plus bx plus c can be written as a times here q2 is px square plus qx plus r. Then we have here b times the derivative of q2. q2 is px square plus qx plus r, and then we have this term e, right, where a, b and e are the constants which are to be calculated, right? So a, b, c, e are the constants, right? So we'll express q1 like this, right? So now we can compare this integrand with this one. So q1 is our quadratic polynomial, that is x square plus x plus 1, and q2 is given by x square minus 1. So now let us write q1 as x square plus x plus 1, and here we have the constant a times q2. q2 is x square minus 1. Then we have b, and the derivative of q2. q2 is x square minus 1, and then we have here the constant e, right? So let us simplify this expression. So we have a times x square minus 1. Here we have b times the derivative of x square minus 1 is simply 2x, and here we have e. So now let us rearrange the terms here. So we have ax square minus a plus 2bx, and here we have e, right? So we have ax square, then we have 2bx, and then we can collect these two terms. So we have e minus a, right? Okay, so now we have the left hand side is x square plus x plus 1. Here the coefficient of x square is 1. Here the coefficient of x is 1. So comparing both the sides, the value of a is equal to 1, right? And the value of the coefficient of x is 2b, and here the coefficient of x is 1. So we have 2b is equal to 1. So b is equal to half, right? And the constant term, that is e minus a, is equal to 1. Now taking a is equal to 1 in this equation, we have e minus 1 is equal to 1. So e is 1 plus 1, that is 2, right? So finally, we have obtained the value of A as 1, the value of B as half, and the value of E as 2, right? So now let us substitute these values in this expression. So now x square plus x plus 1 may be written as a is 1. So here we have 1 x square minus 1. Then we have b is half. And here we have 2x and e is 2, right? Okay, so now we have x square plus x plus 1 is equal to this expression. So let us call this integral as I. So now we can write I is equal to the integral for x square plus x plus 1. We can write 1. Here we have x square minus 1 half 2x, and then we have 2 divided by square root of x square minus 1, and here we have dx, right? So now let us write this integral as a sum of three integrals. So we have I is equal to integral x square minus 1 over square root of x square minus 1. Then we have half and 2x over square root of x square minus 1 dx, and then here we have 2 times the integral dx over square root of x square minus 1, right? And obviously we have c as the constant of integration. So now let us calculate the values of these three integrals. So let us call it I1, this is I2, and this is I3, right? So I1 is integral x square minus 1 over square root of x square minus 1 dx. Here we have dx. So now we can write this integrand as x square minus 1 raised to 1 minus half and dx, because here square root of x square minus 1 can be written as x square minus 1 raised to half, right? So subtracting these two numbers, we have integral x square minus 1 raised to half dx, which can also be written as square root of x square minus 1 dx. So now this integral is of the form square root x square minus 1 square dx, and here we can apply a standard result, and the result goes like this, that is integral of square root of x square minus a square dx is equal to x over 2 square root of x square minus a square. Then we have minus a square by 2, and here we have a term containing the natural log. So here we have x plus square root of x square minus a square, right? So if we compare this term with this one, then the value of a is equal to 1. So here the value of this integral is now x over 2 square root of x square minus 1 square. 1 square is 1, 1 square is 1, so we have half, and here we have log of x plus square root of x square minus 1, right? So I1 is given by this expression. So now consider this integral I2. So I2 is a half, and here we have 2x over square root of x square minus 1 dx. Now we can solve this integral by method of substitution. So we can take t is equal to x square minus 1. So dt is equal to 2x dx. And now we can write half, and here for 2x dx we can write dt, and here we have square root of t. So this is half, and we can take square root of t to the numerator. So we have t raised to minus half dt. So this is half, and we can write it the integral minus half plus 1 over minus half plus 1. So this is half, and this is 1 minus half is half, so this is square root of t. And here we have half, so half and half get cancelled, so we are left with square root of t, that is square root of x square minus 1, right? So the value of this integral I2 is given by square root of x square minus 1. So now consider this integral I3. So here we have 2 times, then we have dx over square root of x square minus 1, which can be written as square root of x square minus 1 square, right? So to write the integral of this expression, we'll again use a standard result. So we have this important result, that is integral dx over square root of x square minus a square is given by the natural log of x plus square root of x square minus a square, right? So we'll apply this result to this one. So we have 2, and then we have log of x plus square root of x square minus a square. Our a is 1, so 1 square is simply 1, right? So the value of I3 is given by this expression. So viewers, this is how we can find out the values of I1, I2, I3. So now to get the value of this integral, we can add all these three integrals, that is I2 plus I1 plus I2 plus I3. So I1 is x over 2 square root of x square minus 1 minus half log of x plus square root of x square minus 1. Then we have I2 is square root of x square minus 1, and then I3 is 2 times log of x plus square root of x square minus 1, right? So now see here, we have these two like terms, so we can take square root of x square minus 1 common, so we have x over 2 plus 1, and then here we have again two like terms, so this is 2 minus half, and we have log of x plus square root of x square minus 1, and obviously here we have the constant of integration, right? So now we can rewrite this integral I as the square root of x square minus 1, x over 2 plus 1, and here we have 4 minus 1, that is 3. So this is 3 by 2 log, and here we have x plus square root of x square minus 1 plus c, right? So this is the required expression for the indefinite integral of this function, right? So this is how we can find out the indefinite integration of the functions of this form, or the integrands of this form q1 over square root of q2.